So let's take this information that we've just got on this sheet of paper and our cast diagram that we've just drawn, and let's start using that to help us solve some equations. So hopefully it's going to make more sense why we're spending all this time on it, because we'll see how it helps us solve some equations. So the very first equation that we're going to look at is we're going to solve sine of x equals 0.6, and this is going to become really important, particularly at higher, for 0 being less than x being less than 360 degrees. So here we're working in degrees, so our answer, our x's that make this true, will all be in degrees. Now that detail will come in and be super important shortly. We'll get to that really in the second video. So let's have a look at solving this. Well, the first thing we need to do if we're going to solve this is do an inverse sine. Now you remember that from way back when you were doing trigonometry, the first time you met it, the inverse sine of 0.6. You can calculate what that is. Put that into your calculator. It should churn out 36.86989 degrees. Now, that is a value, and it is between 0 and 360, so it's a solution, but it's not the only solution. So I'm going to show you that from two perspectives, and really this is up to you which one of these two methods you use. The first way you can think of it is on a graph. So I'll show you that first, and then I'll show you on the cast diagram how it works. So 0.6 is, say, here. Well, wait a second. The graph hits a height of 0.6 here, and it hits a height of 0.6 again along here. Well, this value is clearly 36 point, I'll just round at the moment, 36.9 for our value. Well, we've come along this stretch, but we've got a matching stretch here to our graph. Now remember, that's 180. So if I want to find the second value, I need to come back from 180 the same amount as I went along from 0. So I want to do the calculation 180 take away 36.86989. And actually we can work that out, and that will give us, hey, I thought I had this written down. I do, 143.130. That will do in terms of accuracy 10, and we're going to round that to 143.13 degrees. We'll keep 2 decimal places of accuracy is more than enough here. So that is method 1. That is perfectly okay to use. Method 2 would be to use our cast diagram that we just drew. So first thing, we're going to label up CAST. Now here we've got sine of x, and it gives us a positive value. And remember, these letters represented which of the graphs is positive. So sine is positive here when they're all positive, and it is positive here. It wasn't positive here, and it wasn't positive here. That's what the only tan was positive here, only cos was positive here. So our value, when we did sine to the minus 1 of 0.6, we got a little angle in here, which was 36.869. But by symmetry, there is a second angle, which is that angle there. Well, how can we find that? Well, from our diagram, we can see we can go 180, take away, and these two match. So 180 take away are 36. So 180 take away 36.869. And from what we did a minute ago, that gives us 143.13. So you can either look at the graph and use the graph to help us, or we can use a cast diagram to help us figure out our angle. Now, both have their advantages and both have their disadvantages. So I'm going to let you choose which one of them that you think is easier to understand. This one takes a bit of practice, but once you get used to it, will make a lot of sense. And in fact, you'll find that this section up here, if this is all of them are positive because there's an angle x, this is always 180 take away x. You don't necessarily need to draw a diagram every one time. This is always 180 plus x, and this one is always 360 minus x. So you can kind of write those in to help us in a minute. So I'm going to give you one to have a go at, and then I'll give you a solution to that in a minute. So what I want you to do is have a go at solving cos of x equals 0.2. You can use either method. I will run through the answer to that in the next little video. So come back for the next little video, and then we'll do another few solving ones.